Hello my dear students, welcome to my channel Mind Target 100%. I think all of you have must seen my last videos. In the last classes we have completed momentum, application of momentum, impulse, application of impulses. We derived how derive law of conservation of linear momentum and also derived law of conservation of linear momentum from Newton's third law of motion. And what are the applications you know. So today we have to discuss about the recoil velocity, one of the most important application of law of conservation of linear momentum. डिस्टेंस कवर करके लौट आता है गन, ओके वो पढ़ाएंगे. फिर हो गया while firing the gun must be held tightly to the shoulder. Flight of rockets and jet planes. When a man jumps out of a boat to the shore, explosion of a bomb, person left on a frictionless surface. These are the common examples and applications of law of conservation of linear momentum, recoil velocity. First we have to discuss what are the common examples. Actually maximum examples what are the connected with Newton's third law of motion, they are based upon the law of conservation of linear momentum. Why? Now law of conservation of linear momentum also derived from the Newton's third law of motion, what we already proved that one. So first one we have to discuss about the what recoil velocity. What is recoil velocity? What is recoil velocity? Let us listen, discuss. The velocity with which a gun moves backward after firing a bullet is known as recoil velocity. बंदूक मारते हो, जब बंदूक पकड़े हो उसमें बुलेट हो रेस्ट में है, सो टोटल मोमेंटम कितना हुआ? 0. आफ्टर फायरिंग bullet is moving, gun is also change its position. Okay, so that means total momentum before collision is equal to total momentum after collision. Total momentum before collision is how much? 0. Total momentum after collision is how much? We have to calculate. So let us discuss one by one. That is okay. So that's why the gun recoils obey the conservation of linear momentum. Okay, let M, capital M, mass of the gun. This is the mathematical expression. This is the mathematical expression. V, velocity of the gun. Small m, mass of the bullet. Mass of the bullet. Small v, velocity of the bullet. Velocity of the bullet. You can consider this one is suppose one system. So before firing the momentum of gun and momentum of bullet 0 because they are at rest. ये पहले जब तक आप फायरिंग नहीं किए तो रेस्ट में थे, तो टोटल मोमेंटम कितना हो गया? बिफोर फायरिंग हो गया 0, दैट इज लिनियर मोमेंटम. ओके, नाउ आफ्टर फायरिंग so momentum of the gun mv, momentum of the bullet mv, it is capital M, capital V, small m, small v. So after firing the total momentum of the system, the momentum of gun, momentum of bullet is equal to how much? Total momentum of the system mv plus mv, equation 1. Any problem? Okay, now due to lack of space I am erasing. Now what will happen? What is the law? Law is total linear momentum before system, total linear before collision, before firing, total linear after firing, total momentum after firing how much? mv plus mv Before collision is how much? 0. It is the momentum of the gun. It is the momentum of the bullet. This is before firing. This is, sorry, it is after firing. After firing. This is before firing. Before firing. Now, what you are observing? MV is equal to minus MV. So, V is equal to, capital V is equal to, capital V is equal to minus MV by, this is known as, suppose this is equation 2. This is known as recoil velocity, and this equation 2 represents the recoil velocity of gun. Now what you are observing, V directly proportional M, directly proportional to V, but inversely proportional to the mass of the gun. That means heavy gun recoils with small speeds, and small gun means light gun recoils with large speed. Okay, and this negative sign indicates the velocity of the gun is opposite to the direction of the velocity of the bullet. Bullet forward direction में गया, gun backward direction में आया. But don't think that bullet जितना स्पीड में जाएगा gun उतना स्पीड में आएगा ना. थोड़ा सा कम स्पीड में थोड़ा सा हल्का डिस्टेंस कवर करके आ जाता है, धक्का लगता है. That's why I told while firing the gun must be held tightly to the shoulder is one of the application or example of the practical example of the principle of conservation of linear momentum. Why? This should save hurting the shoulder. When the gun is held tightly, the body of the shooter and the gun behave as one body. Again I am repeating. अगर आप ढीला रखोगे ना कहीं चोट लग जाएगा, तो आप उसको बहुत जोर से टाइटली, while firing the gun must be tied tightly to the shoulder. Why? To prevent from hurting the shoulder. When the gun is held tightly, the body of the shooter and the gun behave as one body. Total mass become large. बंदूक का मास, बॉडी का मास मीन्स शोल्डर का मास ज़्यादा हो गया तो पकड़ लिया, एक बॉडी हो गया. तो अभी क्या बोले, हेवी गन रिकॉइल्स लेस. तो अभी क्या होगा ना, मास ऑफ द बॉडी बिकम्स मोर, सो द मास बिकम्स लार्ज, देयरफॉर रिकॉइल वेलोसिटी ऑफ द गन एंड द गन रिपल वेलोसिटी ऑफ द गन एंड द बॉडी बिकम्स स्मॉल. समझ में आया? बंदूक जिस टाइम में चलाते हो उसको जोर से क्यों पकड़ना चाहिए, समझ में आया ना? तो बंदूक का मास, बॉडी का मास, जो शोल्डर का मास एक्ट एज वन बॉडी. अभी मास ज़्यादा हो गया, ये मास हो गया तो ये भी इन्वर्सली प्रोपोर्शनल हो गया, इन्वर्सली. ओके, यूजिंग दिस वन वी कैन कैलकुलेट सम न्यूमेरिकल प्रॉब्लम्स, वी कैन सॉल्व दैट न्यूमेरिकल प्रॉब्लम्स. Okay, all of you write numerical, that numerical, one numerical I will solve and two numerical I will give you. Suppose a bullet of mass 100 gram, bullet of mass, question is given, I am reading the question first. A bullet of mass 100 gram is fired from a rifle of mass 20 kg. देखो राइफल हो गया, जो बंदूक लेते हो वो 20 kg का. ओके, और बुलेट का मास 100 ग्राम विथ ए स्पीड ऑफ 50 मीटर पर सेकेंड. किसका स्पीड? बुलेट का. कैलकुलेट द रिकॉइल वेलोसिटी ऑफ द राइफल. सो फर्स्ट यू राइट गिवन mass of the bullet, mass of the bullet is how much? 100 gram. Okay, as it is given the mass of the gun, it is how much? It is given 20 kg. Velocity of the bullet is how much? V is equal to 50 meter per second. So for numericals I have already told what are the steps required. देखो ये SI इसको कन्वर्ट करो, कितना हो गया 100 ग्राम डिवाइडेड बाय 1000, कितना आया, कट गया 1/10, दैट मीन्स 0.1 kg. Now you have to calculate. Now all the systems are in same units. You have to calculate recoil velocity. Recoil velocity V is equal to minus mv by m, minus कितना minus 0.1 V 50, okay, divided by capital M 20. So if you solve this one, how much you are getting? You are getting minus 0.25 meter per second. This negative sign indicates that velocity of the rifle is opposite to that velocity of the bullet, and the velocity of the bullet is always opposite to that of velocity of the gun. देखो कितना कम डिस्टेंस गया, देखो यहाँ से राइफल का जो हुआ बंदूक का वेलोसिटी ऑफ गन इतना ही बेटा आया 0.25 विथ माइनस, मतलब बहुत थोड़ा सा पीछे जाएगा तो तुमको चोट नहीं लगेगा, बिकॉज इट एक्ट्स एज ए वन बॉडी, मास ज़्यादा हो गया. ओके, थैंक यू. इन दिस वे यू हैव टू सॉल्व न्यूमेरिकल प्रॉब्लम्स यूजिंग दिस फॉर्मूला. थैंक यू. हैव ए